All right, so I'm going to talk today a little bit about the operation of a mid and high efficiency furnace, and compare that to the old school basic furnaces. Mid efficiency furnaces are mentioned in your ILM. They didn't last very long. Mid efficiency furnaces were probably only popular for 10 years ish, 10, 15 years. Um, High efficiency furnaces have been much more enduring, right? They went from basic furnaces. They said, "Oh, we can get a little more heat out of them." And they designed the mid efficiency, and then very shortly thereafter they said, "Well, you know what? With a couple more tweaks, we can make this highly efficient." And so the mid efficiencies kind of went away. They didn't have a long run, but there's still some out there, and so you should know about them, a little bit about them. What I'm going to do is I'm going to compare the mid and high efficiency furnaces to the basic furnaces here, and just kind of give you an outline of how the equipment operates. Um, the difference between a mid and a high efficiency furnace is all in the construction of it, the way the heat exchanger is built, and whatnot. The control system virtually the same. Um, Varies by manufacturer, of course, but the principles of the control circuit on a mid and high efficiency furnace are both the same. So I'm going to kind of refer to them both as an efficient furnace in this video. To start out with, in our basic furnace, the old school um, standing pilot light. Once the T-stat closed, as long as there was a pilot light that was operating the thermocouple, as long as there was a pilot light that was holding that was on the thermocouple, which was holding the enabling the gas valve, as soon as the thermostat closed, um, we powered the gas valve, which shot gas onto that pilot light, and the burner lit. Right? It was pretty simple. Um, the only safety switch in there was the high limit switch. Electrically, that's the only electrical component that was in that initial function, and I mean, it just stayed closed unless the fan broke, or the fan belt or broke, or the fan motor quit, or whatever, and caused the plenum to overheat. But there really wasn't a lot of controls there. Once the burner heated the plenum, we had that bimetal strip which told us when the plenum got hot, which kicked the fan on. When the thermostat opened, that shut the burner off. And then that combination switch, the same one that turned the fan on, would turn the main fan off when a sufficient amount of heat had been pulled out of that heat exchanger. Um, right? Wanted it set properly so that we didn't, we got all the heat out that we'd paid to make, um, but we didn't start blowing cold air around the house, right? So that was kind of the way they were. From here to here, the mid and high efficiency furnaces function exactly the same way. The big difference between the with the efficient furnaces over the old base furnaces is, or basic furnaces, is that when the thermostat closed, it did not. Efficient furnaces don't turn on the gas valve. Don't turn on the gas valve. Okay. Efficient furnaces don't have a standing pilot light. What happens when the thermostat closes in an efficient furnace is it turns on the combustion fan, which is a small fan that blows air through the the gas chamber. the combustion chamber, sorry, that's the proper word for it. So when the thermostat closes, that combustion fan kicks on. When the combustion fan is running, if we get airflow coming into the furnace through that combustion chamber and then out the flue, there is an air proving switch that closes. And it's the air proving switch that actually operates our gas valve. Or sorry, the air proving switch does not operate the gas valve. The air proving switch, let's move this down. The air proving switch operates the igniter, which then operates, once we prove that we have an ignition source, then we turn on the gas, open the gas valve, and as long as the flame proving device actuates, the burner stays on. The burner actually will obviously kick on right here. The flame proving device shuts off the igniter and keeps the burner on. So there's a little bit of an overlap there, right? So it's a little different. But, so that air proving switch, it does the same. One of the jobs that it does, the same as that takes place of the pilot light, is it makes sure that there's no buildup of gas in that combustion chamber, right? The combustion fan kicks on, it purges everything that's in the combustion chamber out. The air proving switch tells you that yes, the air is moving, so if there was any leftover gas in there, it's all blown out, it's all cleaned out. The pilot light made sure there was no buildup of gas, because if there was a buildup of gas, it lit, right? There was a standing flame there. We don't have that, so we have to make sure that we've got any leftover gas moved out before we start the igniter, or we could have an explosion.